Hello guys, today I'm just making a basic past paper walkthrough for the exam board Pearson Edexcel International Advanced Level with the paper reference code WPH11/01. The time for this paper is about 1 hour 30 minutes, and this is for the subject physics, so with the unit 1 mechanics and materials paper. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's start with the video. Alright, so what we have to do first is to read the instructions given in the paper. So the instructions is to use a black ink, so that's very important, and show all your working and include all the units where appropriate. So for this physics Edexcel paper, you have to show all the units, meaning like if you say 10 newtons times 15 meters, so you have to show the units. It's very important in while solving the question. And the total mark for this paper is about 80, so we can start with the first question. So section A, answer all questions. For questions 1 to 10 in section A, select one answer from A to D and put a cross in the box, so meaning that your answer is going to be showcased as a cross in the box. And if you change your mind, you can put a line across that and then mark your new answer with a cross again. Okay, so the first question is stating that a student walks for about 6 seconds. The displacement time graph for the student is shown. Which row of the table shows the final displacement and the velocity of the student? So we can see that there's a graph here. Since we can see that there's a graph, we know that our final displacement is going to be the one in the top. So it's roughly about 2 meters. This is going to be our final displacement that goes across. And your velocity is going to be, since this is a displacement velocity graph, this is a displacement time graph, sorry guys. Since this is a displacement time graph, we're going to find out the gradient in this case, since we know that the gradient is equivalent to the change in velocity, right? So we can find out the gradient in this case. So we're just going to take it in 2 points. So we're going to take this point here and this point over there. So it's going to become 6, 2 and 2, 0. You can do rise over run, that's also okay. So rise over run method is where we are going to find out the gradient, which is m. It's equivalent to the rise. We know the rise is about 2 divided by the run, which is a difference about 6 and 2, so 6 minus 2. If you plug these values in your calculator, you're going to get an answer of about 0.5. So your gradient is going to become 0.5. So that's going to become option A. So A is the correct answer in this case. So you're just going to put a cross there. Alright. Physical quantities may be vectors or scalars. Which row of the table is correct? So in this case, we have to observe which one's correct. So if you look at all the options, option D is the correct answer because force is a vector, mass is scalar, and acceleration is vector, so it all correlates with each other. So D is going to be your correct answer in this case. Question 3, the velocity time graph for a particle is shown. Which of the following is the displacement time graph for this particle? So out of looking at these graphs, we can see that the velocity is a straight line downwards. Okay, so and it's going to be the graph 3A. Alright, 3A is the correct answer. This is because if you look at graph B, right, it's not correct because the velocity in this case should be always 0. So we can see that in graph A, it's starting at 0 point. If you look at graph C is also incorrect because the velocity should always be positive in this case. And graph D is incorrect because, let's say, because velocity is 0 except for a very short time. So in this case, graph A seems the most reasonable to answer this question. Okay. Alright, let's move on to the next question. Now, question 4 is the diagram shows a student during a parachute jump on a windy day. The vertical component of her velocity is about 5.0 meters per second. The horizontal component of her velocity is 8 meters per second. She descends at an angle of theta to the vertical. So we can see a nice little diagram there. Which row of the table gives expression for the magnitude and angle of the student's resultant velocity? So to answer this question, what we have to do is we know that the resultant velocity is just going to be tip-to-tail method. So we're going to find out what's the velocity by using Pythagoras theorem. So if you say by Pythagoras theorem, we know, right? We know that hypotenuse squared is equivalent to the height, which is squared. So we know that the hypotenuse, which is squared, is equivalent to the height squared plus the base squared. And to find out the hypotenuse, that's going to be the square root of the height squared. In this case, it's just going to become, if you look at it, it's going to become height squared. So that's roughly about 5 squared plus the base 8 squared. So this is going to become your hypotenuse in this case, which is going to become the magnitude. So indirectly, we can see in the options that it could be either option C or D. Now we have to find out the theta angle. So now the angle to this point is going to be here. This is going to be theta. If you do opposite, adjacent, and the hypotenuse. So indirectly, we can use the concept of SOHCAHTOA to find it out. So we can see that there's the opposite and adjacent. We have to use tan theta is equivalent to opposite divided by adjacent. Indirectly, we're going to rearrange this to make theta the subject of the formula. So it's going to become tan inverse of opposite, which in this case is 8. 8 divided by the adjacent, which is 5. And that should give you your angle. So you can see that we have found out the magnitude and we have found out the angle for theta. So that's roughly tan inverse. That's going to be option C in this case. Right? Yeah, okay. It's going to become option C, 4C, because we know the magnitude is the square root of 8 squared plus 5 squared. So we got that. And the theta angle is tan inverse of 8 by 5. Right, so C is the correct answer. Alright, let's move on to the next question. An object on the moon falls a vertical distance of about 0.32 meters from rest in a time of 0.63 seconds. Which of the following expressions gives the acceleration due to gravity on the moon in meters per second? So what we have to do here is that we have to look at this using SUVAT equations. So meaning that I have the formula sheet here. By the way, in the exam, look at the last page of your exam paper. That's usually where the list of the formula and data will be there. So just keep that in mind. Look at the last page of your exam paper. That's where all the formulas are being placed there. So your SUVAT equations is going to become S is equivalent to UT plus half AT squared. So since we know the vertical distance is 0.32, and we know it's starting from rest, so that means the initial velocity is going to be 0. We know the time is 0.63 seconds. We know the distance to be about 0.32 meters. By the way, the S just represents distance. Okay? So indirectly, we can find out what acceleration is due to gravity. So in this case, it's going to become 0t. So indirectly, the ut cancels out. So you're going to get S is going to half AT squared. So S we know is 0.32 is going to half a 0.63 square. This is going to go there, so it's going to 0.63 square. A is equivalent to 0.32 times 2. A is going to become 0.32 times 2 divided by 0.63 square. So out of all these options, we can see that option C is the correct answer because it's really equating to what we have found using a SUVAT equation. Okay? So we can see, yeah, 2 times 0.32 divided by 0.63 squared. So C is going to be your correct answer in this case. All right, let's move on to the next question. Question 6. The graph shows how terminal velocity varies with mass for small spheres of equal diameter falling through a viscous liquid. So we can see that there's a terminal velocity against mass. Which of the following describes the gradient of the graph for a liquid of greater viscosity? So in this case, it's going to be option B because there's going to be a smaller gradient. Now the reason is for this is because since there is a, let's say, since there's greater viscosity, this would indirectly, it would reduce the terminal velocity, and which would indirectly give us a lower gradient. So that's why it's going to be B, because it's saying that it's going to be a smaller gradient in this case. So let's move on to the next question. So, question 7. A person is pushing a trolley at a constant velocity. The floor exerts a force of P on the person. the person exerts a force of about Q on the trolley exerts a force about R on the person, and the total drag force on the trolley is S. Which pair of forces is Newton's third law pair? So we're just gonna draw a person here. The diagram already has it though, and he's pushing a trolley, so this is going to be the trolley in this case. So the floor exerts a force P, so we know that there's going to be a force P here acting, and the force and the person exerts a force Q on the trolley, so it's going to be a forwards momentum of about Q, a force of Q. The trolley exerts a force of R on the person, so it's going to be on the reverse direction, and there's going to be a total drag force on the trolley, which is S. That's going to be S. So we have drawn, by the way, draw the free body diagrams in this case and label all the forces and the arrows. So which pair of forces is Newton's third pair law? So we know that Newton's third law just states that when two objects collide or when they interact with each other, they exert equal and opposite forces on each other, right? So that's going to be Q and R. So in this case, the answer is going to be B, because we know that Q and R are equal and opposite to each other, and they act, yeah. So when two objects interact with each other, they exert equal and opposite forces towards each other. So Q and R is the answer in this case. Yeah, 7B. Okay. Let's move on to the next question. Next question. A wire breaks when a tensile force T is applied. The second wire, made of the same material, has twice the diameter. Which of the following is the force required to break the second wire? So I would like you guys to use your formula sheet and write down the tensile force and the let's say the stress equation. That's very important. So then we know that stress equation is equivalent to force divided by area, and we know that the force is equivalent to the tensile stress times the area. Now the area in this case is going to be pi r square, and we know that the first wire would have a diameter, has twice the diameter, so it'll have the diameter x, and the second wire, right, would have the diameter 2x. So which one gives you the force? So T just represents the must be the let's say the tension in this case for the same stress. So we have to find out the force required to break the second wire, so that's going to be actually double the thing. So it's going to be 8A, since we know, yeah, because B is not correct. Now the reason why B is not correct, because doubling the diameter is going to give 4 times the cross section. This requires like 4 times the tension for the same stress. C is also incorrect because, let's say, increasing the diameter, it'll increase the cross section. So this will require a greater tension, let's say, for the same stress, but not less in this case. And D is also incorrect because, let's say, increasing the diameter, it'll also increase the cross section, indirectly requiring a greater tension in this case for the same stress. So it can't be B, C, or D in this case. So it's just going to be A, since you're doubling the diameter. It's going to have twice the diameter, so for that same tension stress. So 8A is going to be your correct answer. All right. Let's move on to the next question. Now, beam is balanced on 2 supports as shown in the diagram. So we can see a nice little diagram. The beam has a weight of W and reaction forces at the 2 supports of P and Q. Which of the following statements about the magnitudes of the forces is correct? So it's going to be 9C. This is because Q is going to be greater than P. Now, the reason why it's 9C, it can't be A. It's not A because the moments must balance, let's say, about the center of mass. B is also incorrect because the balance is roughly about the left support. And D is totally incorrect because the reaction must be equal to the weight. So it's going to be 9C in this case. Okay, which row, next question, which row of the table contains 2 units that are not equivalent to each other? So by looking at this, it's not equivalent to each other, so it's going to be 10B. Now the reason why it's 10B, because A is incorrect, because 1 watt is defined as 1 joules per second, so this is correct. C is also not the correct answer for this case, is because 1 Newton meter is also equivalent to 1 kilogram per meters per second square. And D is also incorrect because the joule is a unit of work, so meaning work done is equivalent to the force times distance. So this is also correct. So which is not equivalent to each other. It's going to be 10B in this case. All right, 10B in this case. Okay, let's move on to the next questions. Okay, next question is section B. Now, okay, so slow-moving asteroid A was hit by faster asteroid B. Asteroid B was absorbed by asteroid A as shown. So we can see a nice little diagram. State the principle of conservation of linear momentum. So this is something that you have to learn. We know that the sum, well, let's say the total moment, we're going to use that. Let's say the total momentum before a collision is equivalent to the total momentum after a collision, provided that no external force, or let's say the resultant force in this case, X, no external force X, or let's say in a closed or isolated system. Okay, let's move on to the next question. Before the collision, asteroid A had a velocity of about this and a momentum of about that. Find out the mass of the asteroid. So the mass of the asteroid, we have to use the momentum formula, which is equivalent to P is equivalent to mass times the velocity. And we have to rearrange this to find out the mass, which is going to become the momentum divided by the velocity. So indirectly, mass is going to become the momentum, which is 1.80 times 10 raised to the power 17. Right, write the units. By the way, very important that you write the units, divided by your velocity, 2.19 times 10 raised to the power 3 meters per second. Is going to divide using a calculator, so just plug in the values. I'm just going to use the calculator in this case. So if you use the calculator, you get 1.80 times 10 raised to the power of 17 divided by 2.19 times 10 raised to the power of 3, which is going to give you an answer of about 8.219 times 10 raised to the power of 13 kilograms. So now what you can do is we have to round this off. So you're going to get mass is equivalent to 8.22 times 10 raised to the power of 13 kilograms. So this is going to be answer for about 2 marks. You're showing your formula gets you one of the marks, and showing your final answer also gives you one of the marks. Show your calculation as well. It really helps. Alright, let's move on to the next question. Calculate the velocity of the asteroids after the collision. The mass of the asteroid B was that, and the velocity of asteroid B before the collision was that. So now, for this one, I would like you guys to use the concept of the momentum and conservation. So, conservation of moments, right? We know that the momentum is conserved as long as no external force acts on it, right? So we know that the total momentum, right, we can write that down, total momentum before the collision is equivalent to the total momentum after the collision. Okay? So it's using P equals m times v, where the momentum is equivalent to the mass times the velocity in this case. So I would like us to label our, I would like us to use this formula, m1 u1 plus m2 u2 is equivalent to m1 v1 plus m2 v2. This is the mass of 1, which is the mass of asteroid A. Let me just get my formula sheet just to see if the formulas are all correct in this case. Yeah, this is not, by the way, this formula is not there in the formula sheet, so what you have to do is you have to, it's your choice whether you want to learn this formula, or you could just directly just plug into the momentum formula and equate it on both sides. That could also work in this case. So if you look at the formula sheet, yeah, there seems to be, yeah, okay. So mass 1. So the mass 1 in this case is going to be the mass of the asteroid, which we know is about 8.2 2 times 10 raised to the power 13. So we know that before the collision, we know that asteroid A had that much velocity and a momentum of about that before it collided. So calculate the velocity of the asteroids after the collision. So the velocity of asteroid B before the collision was that. So indirectly, we're just gonna find out what is the what is the momentum before and the momentum after. So in order to do that, we have to look at the masses. So what I'm going to do is I'm going to write this all down here so we can see it more clearly. So asteroid A had a velocity, so this is going to be the velocity of asteroid A, which is 2.19 times 10 raised to the power 3 meters per second, and the momentum of asteroid A, which is going to become 1.80 times 10 of A before, so 1.8 times 10 raised to the power 17. And the mass of asteroid A, so the mass of asteroid A is roughly about 8.2 times 10 raised to the power 13 kilograms. So we have that kind of information written down. Now we know the velocity in this case. So what we're going to do is we're going to write down the mass of B as well, so we can see that here clearly. So 5.90 times 10 raised to the power of 12, and the total velocity, the velocity of B, so we can say this before is equivalent to 15.0 times 10 raised to the power 3. So what we have to do is to calculate the velocity of the asteroids after the collision. So now in order to do this, first of all, we're going to have the momentum of asteroid A before it, and we're going to add it with the momentum of the asteroid before momentum of the asteroid B. So what we're going to do is momentum of A, right? Let me just reload this again. The momentum of A before plus the momentum of B before. So it's going to give us equivalent to the momentum of A before, we know is 1.80 times 10 raised to the power of 17. Okay, 10 raised to the power of 17 in this case, which is kilograms meters per second. So I'm just going to write that down, which is also equivalent to in this case. So we're going to write kilograms meters per second, put that in brackets. Okay, and you're going to add it with the momentum of B before. So momentum of B, we're going to use P equals mv. So mass of asteroid is 5.90 times 10 raised to the power 12, and we're going to multiply that by your velocity in this case, which is 15.0 times 10 raised to the power 3. This is going to be your total momentum. Actually, this is going to be the total momentum before. So total momentum before in this case. So we're going to put 1.8 times 10 raised to the power 17. I'm just going to plug these values just to get some good rounded off value. 5.90 times 10 raised to the power of 12 brackets times 15.0 times 10 raised to the power of 3. Put that in brackets as well. And we can see that it's going to give us 2.685 times 10 raised to the power of 17. This is the total momentum before, okay, remember, and this is the total momentum after. We have to calculate that. So the total momentum after, this is going to be the momentum of A after. So the momentum of A after, that's going to be, let's say, if you look here, in this case, we're going to check the values, which one we have, and which one we have to look at. So we have to add up all the masses together. So now the reason is because we know if we add up the total mass of both asteroid A and B, and we multiply by the velocity, right? Since we know we have to calculate the velocity of the asteroids, of both the asteroids after the collision, that would indirectly help us get the momentum. So what we're going to do is we're going to write down, to find out the momentum, total momentum after, we're going to do the total mass of asteroids. Okay, total mass of the asteroids multiplied by the velocity. So we know the total mass of the asteroids. We know the mass of asteroid A to be about 8.219 times 10 raised to the power of 13 kgs, plus the mass of asteroid B, which is going to become 5.90 times 10 raised to the power of 12 kgs. And you're going to multiply that by the velocity, which we have to find out in this question. Alright? We have to find out the velocity. Alright? Multiply by the velocity. So if I plug these into our calculator, we're going to get just for 3 marks, we just need to show all our working. I'm just writing down all the working for you guys just to see how to solve this question and to understand how this works. So if you add this, right, you get 8.809 times 10 raised to the power of 13 V, okay? And once you do that, we're going to rearrange this, and since we know the total momentum before is equivalent to the total momentum after, so total momentum before 2.685 times 10 raised to the power of 17 is equivalent to the before 8.809 times 10 raised to the power of 13. And velocity is 2.685 times 10 raised to the power of 17 divided by 8.809 times 10 raised to the power of 13, which is going to give you a final answer of about 2.685 times 10 raised to the power of 17 divided by 8.809 times 10 raised to the power of 13, which is going to give you a final answer of about 3048.01 meters per second. You can round this off in standard figures, so it gives you 3.048 times 10 raised to the power of 3. If you plug that into your calculator, you should be getting the same exact value. I'm just going to check that. Yeah, okay. Meters per second. This is going to be your answer. Okay? So it's going to become 3.048 times 10 raised to the power of 3 meters per second. This is going to be our final answer. Alright, let's move on to the next question. Question 12. Okay. Question 12 is the diagram shows a lift system for moving people up and down a building. There is a counterweight to balance the weight of the lift. An electric motor is used to raise and lower the lift. Explain how the counterweight affects the amount of work required from the electric motor to raise the lift. So the counterweight can be seen here. So what we have to do is we have to answer this for about 2 marks. So meaning we can say that the amount of work from the electric motor is reduced. Okay? Now because there is an energy transfer between the counterweight and the lift. Now this is the correct way of answering this type of question. Or you could also mention, because let's say the counterweight, because it contributes to the total work done on the lift cage. Or you can mention that the total work done on the lift cage is like the sum of the work done by the counterweight and by the motor. So as for 2 marks, this should be more than enough. Alright, so question B is the electric motor raises the lift through a height of about 40.0 meters and in a time of about 30.0 seconds. So we know that the height in this case is 40.0 meters, and we know the time is about 30.0 seconds. We know that the output power of the we have to show that the output power is about 12 kilowatts. So we know that 1 kilowatt is equivalent to 1,000 watts. So to show the output power, we need to use a formula in this case. So we're going to use the formula. In your formula sheet, you're going to use work done, which is the change in work done is equivalent to the force times the change in distance, or you could use the gravitational potential energy formula, okay, in this case. So the use of conservation of energy, we know that the energy is going to be for lift in this case. So actually it would be better if you use gravitational potential energy, since they have specified the height in this case. So what we're going to do is we're going to do the change in gravitational potential energy formula in this case. So it's going to become gravitational potential energy, mg, and change in h. Okay? And then you're going to use the equation of power to find out the output power, which is going to become the watts divided by the time, since we know that time is given. So what we're going to do is for the counterweight, or let's say in this case, we're going to find out how much is the gravitational potential energy. Now this is for the counterweight. So the counterweight is going to become the mass of the counterweight is about 1,300 times the gravitational potential energy is 9.81 times the height in this case is going to become 40, right? So 40 m. So it's going to become, if you plug those values into your calculator, you're going to get an answer of about 510120 joules. Okay, now for the lift, you're going to use the same formula. We know the mass of the lift, the total mass of the lift and the people is 2,250 times 9.81, which is the gravitational field strength, times the height, which is again 40. Now this is going to give you an answer of about, let's say, 882,900 joules. Now what you're going to do is you're going to subtract these two values because we have to find out the energy required in this case. So it's going to become 882,900 minus 510120, which is going to give us a value of about, let's say in this case, 372,780 joules. Now this is going to be our total joules in this case. So this is the work done, or you can actually use this as power is equal to energy transferred over time. So we can use this formula as well. So the conservation of energy. So we know that the power is equal to energy over time. So the energy required in this case is going to become 372,780 joules divided by the time, which is given to us about 30 seconds. And if you divide this, 372,780 divided by 30, it's going to give us an answer of about 12,426 watts. So if you round this off, you have to make this into kilowatts, or since we have to show that it's in kilowatts, so we have to divide this by 1,000. So 12426 watts divided by 1,000. Since we have to show this in kilowatts, it's better to show it in kilowatts. So you're going to get roughly about 12.426 kilowatts power roughly. So the power is going to become 12.4 kilowatts. This is going to be an answer in this case for about maximum of about 4 marks. Okay, alright. Let's move on to the next question. Now the electric motor dissipates energy. Dissipates just means it moves out to the surroundings or it spreads out energy to the surroundings at a rate of about 3,600 watts. Bear in mind the efficiency of the electric motor. So now the efficiency formula is given in your formula sheet, so do check that. So efficiency is going to become equivalent to, let's say, the useful, okay, the useful, since we know that it's power, so we're going to use a power formula, the useful power output divided by the total power input. So the useful power output in this case is going to become 12.4 kilowatts. So we're just going to convert this all into watts, since that would be a better approach. So 12.4, so we know that it's 12,426 watts divided by 12,426 watts plus the total power output is 3,600 watts. Okay, so we're going to add them up. So that's going to be the total useful power output, 12,426, since we know that the output power of the electric motor is about 12 kilowatts. So we have to add that with your 3,600 watts. That's going to give you an answer of about 0.775. This is going to be your efficiency. So sometimes you can leave this as a percentage, but it would be better if you leave this as a decimal. So 0.78. So your answer is going to be 0.78 for about 2 marks. Alright, so yeah, this should be correct. Let's move on to the next question. Now, the next question is a Tyrolean traverse is a technique for crossing a deep valley. The photograph shows a climber crossing a river. Using this technique, the climber moves along a rope suspended from the bank on either side of the river. The free body force diagram for the climber is shown below. The weight of the climber is about 650 newtons. So the weight of the climber is about 650 newtons, okay? So we have to know that. And we can see the diagram, and we have to show that the tension in the rope is about 1.3 times 10 raised to the power of 3 newtons. So the first thing is, what we have to do is we have to find out the vertical component of the tension. So in this case, so we know that the vertical component of tension is going to be the horizontal case, okay? So the vertical component of tension, right, is going to become T cos of 76. Since we know in the diagram that the horizontal is going to be the force of cos theta. So that's why we're doing T cos 76. Since there are two of them, we have to sometimes multiply this by 2, okay, since we can see that there's two tensions in this case. So we know that the total weight is going to become 650, so we're going to do 650 is equivalent to 2 times the tensions, in this case is T cos 76. So T cos 76, so indirectly we're going to rearrange this to make T cos 76 is equivalent to 650 divided by 2, alright? So it's going to become, let's say, T cos 76 is equivalent to 650 divided by 2. That's going to give you roughly about 325. So it's going to be multiplied. So it's going to be T is equivalent to 325 divided by cos of 76. So the tension in this case is going to become, divided by cos 76, it's going to become actually 1,343.4 newtons. And if you round this off, or let's say convert this into standard form, so the tension is going to become 1.34 times 10 raised to the power of 3 newtons. I'm just going to confirm this in my calculator if this is correct. And yeah, this should give you an approximate answer. So 1.34 times 10 raised to the power of 3 newtons. This is going to be the answer for about 3 marks. Alright, let's move on to the next question. Now the rope has an unstretched length of about 120 meters as shown below. Determine the strain in the rope while it's supporting the weight of the climber. You may ignore the weight of the rope. So strain, we know strain's formula. If it's in your formula sheet, so strain is equivalent to the change in x divided by x. So this is the extension, top is extension, and it's divided by x. So in this case, what we're going to do, instead of cos 76, we're going to use sine 76, because we have to find out now the vertical stretch, right, the vertical part of it. Or we could use cos 14 as well, but in this case we're going to stick with that, and we're going to use this formula as well. So in order to do this, what we're going to do is we're going to add the original length, right? We know that this top part is the, I think the top part is the extension and bottom is the original length. So in order to solve this, is we're going to add up, let's say, the total of the original length plus the extension in this case, right? And we're going to divide it by 2. So which is going to become, since we have to divide it by 2, what we have to do is we have to rearrange this in a way that we understand that the total unstretched length, which is the original x, is going to become 120 meters, right? So in order to do this, is we're going to have the x plus the change in x, which is going to be divided by 2. It's going to be equivalent to 60 meters, right? We know that it's going to be roughly about 60 meters, so where are we getting this 60 meters from? So we're going to check where is this going to be divided from. So we know that it's divided from 76. So we're going to multiply that by 2, right? So it's going to become 70, or let's say 60 meters, divided by, since we're halving that, all we're doing is just doing 120 divided by 2, which is going to get 60 in this case. So 60 divided by the sine of 76, since we're finding out the vertical part. And what we're going to do is we're going to multiply this out. Actually, we're just going to do x plus theta x is equivalent, sorry, the triangle delta x. Sorry, so 60 divided by sine of 76. I'm just going to round this off to a decimal now quickly so we can see that it's 60 divided by the sine of 76. So that's going to give you roughly about it's going to be 61.83. So what we're going to do is we're going to do 2 times 61.83, 6, and x plus, we know that x in this case is now 120. So what we know is that this x is going to be 120. So the change in x is going to become, we're going to multiply this value to give us an answer of about, let's say 836, give us an answer of about 123.672. So 123.672 minus 120, since we know x is that. And we're going to find out the strain in this case. Very important that we find out the strain, so we're just going to find out the extension. So 123.672 minus 120. This should give you an answer of about 3.672 meters. This is going to be your extension in this case. Once we know the extension, we're going to divide it by the original length to find out strain. So strain is equivalent to change in extension, 3.672 divided by x, which is the original length, to be roughly about 120 meters. So since this is 120 meters, we're going to divide it by that. So 3.672 divided by 120 meters. So in this case, it's going to become 0.0306. And strain, remember that strain has no units, so you just leave it as it is, or you can leave it as a percentage. So in this case, we're just going to leave it as 0.03. So 0.03. This is going to be answer for about 3 marks, or you could leave it as 3%. So it's alright. It depends on your choice for solving this question and giving its units, either in decimal form or in percentage. Okay, let's move on to the next question. The rope has a cross-sectional area of about that. Okay, and we have to determine the Young modulus of the rope. So the Young modulus in this case has a formula of E is equivalent to the stress over the strain. Okay, and we know that the stress is equivalent to force divided by A, and we know that the strain is equivalent to change in x divided by x. So if we do this, if we do force, right, if you do the Young modulus, right, E is equivalent to force divided by A divided by change in x divided by that, you're going to inverse this, and it's going to become multiplied of the reverse process. So it's going to multiply this by x divided by change in x. So indirectly going to give us f of x divided by A change of x. So your Young modulus is going to become f of x divided by A change delta x. This is going to be your formula in this case. So what you're going to do is you're going to do the stress divided by that. So it's going to become the force. Have they mentioned any forces here? Let me just check. Where's the force in this case? The force we know is 1.34, so we can use that tension in that case. So it's going to be 1.34 times 10 raised to the power 3 times x. We know that x is the original length to be roughly about 120, so we're going to multiply that by 120. We know that the cross-sectional area is 3.14 times 10 raised to the power negative 4 times delta x, which is the extension. In this case, we have just found it out that it's 3.62. So it's going to be 3.63, sorry, not 3.62, it's going to be 3.672. If you plug in your values into your calculator, you're going to get an answer of roughly about, I'm just going to plug these values into the calculator. So 3.14 times 10 raised to the power negative 4 multiplied by 3.672. You're going to get a really big answer actually. So it's going to be 1,394,61304.7 pascals. Okay, this is going to be in pascals, right? Because Young modulus, since stress is in pascals and strain has no units, the Young modulus value is also going to be in pascals. So your Young modulus is going to be equivalent to 1.4, actually 1.4 times 10 raised to the power of 8 pascals. All I've done is I've just converted this into standard form. and this is rounded off to about, there are 7 zeros, so roughly 1 2 3 4 5 6 7. Yeah, it's going to be 1.4 times 10 raised to the power 8 pascals. Okay, all right, this seems to be the answer. Okay, let's move on to the next question. There's a lot of math questions here. Okay, so yeah, student of weight 600 units standing on weighting scales. In a lift, the scales are calibrated to give readings in newtons. The lift moves upwards at a constant velocity, then decelerates to rest. As the lift moves, the student looks at the readings on the scales. Explain the readings on the scales. So, since this is 6 points, we have to give 6 marks. Since it's 6 marks, we have to give 6 points. So the first thing that you can say is that the force, right, the force of the lift, right, on the student, or let's say the force of the scales on the student, is the readings on the scale. So the force of the lift on the student is the readings on the scales. Is the readings on the scales. We're just going to reload the system again so it's more faster. Okay. Then we can mention that at constant speed, let's say at constant speed, okay, the resultant force on the student is going to be 0, okay? Since we know that weight is going to become equivalent to the reaction force indirectly, it's using terminal velocity concept. Then we can also mention that at constant speed, right, the reading on the scales, would be 600 newtons. Okay, or let's say at rest, the readings on the scales would be 600 newtons. And then you can mention as the lift decelerates, the reaction, it becomes less than the weight. Okay, the reaction becomes less than the weight. So indirectly, as the lift decelerates, there is a resultant force. I'm going to mention that. There is a resultant force that's downward. There's a resultant, there's going to be a resultant downward force. Actually, it's going to be a resultant downward force on the student. Now, the reason is because, I'm going to write it down, because the reaction is less than the weight, right? So indirectly, the resultant force is going to act downwards. So as the lift decelerates again, as the lift decelerates, the reading on scales will be less than 600 newtons. Now this is because, we can say because the upward force on the student is less than his weight. So we know if the upward force is less, we know if it's this much and the downward force is more, it's more likely to go downwards. So we know that the upward force on the student is going to be less than his weight. Okay, this is going to be answer for roughly about 6 marks. So let's move on to the next question. Okay, now the next question is mostly going to be about upthrust and fluids. So a hollow brass cylinder with a closed end is floating on the surface of water. The cylinder has a length of about 4.0 centimeters and an external diameter of about 2.1 centimeters as shown. 63% of the volume of the cylinder is submerged. The cylinder contains negligible weight of air. Explain why the brass cylinder floats. Now it floats because, for 2 marks, because there's an upthrust. Which is equal to the weight of fluid, or the weight of water in this case, which is going to be displaced. Okay, and we can also mention that the upthrust, right, is equal to the weight is equal to the weight of cylinder, okay, when it's partially submerged. All right, this is going to be answer for about 2 marks. Or you can mention that the overall density of the cylinder is less than the density of water, and you can also mention that the weight of the water displaced is equivalent to the weight of the cylinder. So you can mention that as well. Now the density of water is given to us about, so the density of water in this case is going to be 1.0 times 10 raised to the power 3. Show that the mass of the cylinder is about 9 times 10 raised to the power negative 3 kilograms. So we know that the density formula is the density is equivalent to the let's say the mass. So I'm just looking for the formula in the formula sheet. Where is it? Yeah, the density is going to become equivalent to the mass divided by the volume. Okay, and we know the mass of the cylinder. We can indirectly find out the volume. So we know that the cylinder has a length of about 4.0 and external diameter. So indirectly we have to find out the volume. So the volume of the cylinder is going to be pi r squared times L. Indirectly it's going to be pi times the diameter. So we know that the diameter is about 2.1. So the diameter is 2.1. The radius is going to be 2.1 divided by 2 since the radius is the half of a diameter. So we're going to divide it by 2. So get 1.05 meters. Times 1.05. Is this in meters? Just confirming. This is in centimeters. So meaning that I think you have to convert this. Yeah, you have to convert this into meters. So this is going to be in centimeters. Sorry guys. You're going to convert this into meters. So 1 meter is 100 centimeters. So 1.05 centimeters is going to be 1.05 divided by 100. That's going to give us roughly about 0.0105 meters. So we're going to rearrange this again. So we're going to find out the volume as pi times radius 0.0105 squared times the length. Since we know that the length is 4 centimeters, it's going to become 4 centimeters. So 4 is equivalent to 4 divided by 100. It's going to become 0.04 meters. So 0.04. So the volume in this case is going to be pi times 0.0105 raised to the power 2 times 0.04, which is going to give us a value of about 1.385 times 10 raised to the power negative 5 meter cubed. Okay, the volume is in meter cubed. Now we can show that the mass is roughly about that, since we know the mass is the density times the volume. So it's equivalent to 1.0 times 10 raised to the power 3 times the volume. This is 1.385 times 10 raised to the power negative 5. Okay, once you do that, 1.0 times 10 raised to the power 3 brackets times 1.385 times 10 raised to the power negative 5. So that's going to give you a value of about 0.01385. Okay, something's up. This is the density of water. Sorry guys, we have to not multiply this by the density of water. Sorry guys, that's why the value is different. So what we have to do is, since we know that we calculated the volume, so we got that part right, we have to know that the volume submerged, right? We know that 63% of the volume of the cylinder is submerged. So what we're going to do is, we know that 63%, right? We know that 63% is 63 divided by 100, which is roughly about 63 divided by 100 is roughly about 0.63. So what we're going to do is we're going to have the volume submerged, so 0.63 times the volume of the cylinder as 1.385 times 10 raised to the power negative 5. Now we're going to do 0.63 times 1.385 times 10 raised to the power negative 5 in the calculator, and you're going to get 8.7255 times 10 raised to the power negative 6 meter cubed. Now this is going to be your volume. Now using this, we're going to do the mass of cylinder, which is equivalent to the mass of water displaced. So we have to show that the mass of the cylinder is roughly about that. So what we're going to do is we're just going to do the mass is equivalent to the density, which is 1.0 times 10 raised to the power 3 times the volume, 8.7255 times 10 raised to the power negative 6. This is going to give you a final answer of about, I'm just going to put this in brackets so we can just see this more clearly. Yeah, so times 8.7255. I'm just using the calculator just to find out the answer. So we get a value of about, yeah, now it should be correct. 8.7255 times 10 raised to the power negative 3 kilograms. So now you can round this off to give you you can round it off to about 8.73 something, because they have rounded out some of their values here, so you're gonna roughly round it up to about 9. So the answer here is showing 8.8 times 10 raised to the power negative 3 kilograms, or you can round it off to about 9. This should be whatever your answer you get, you just round it off. You should get somewhat approximate 9 times 10 raised to the power negative 3 kilograms. Okay, let's move on to the next question. Okay, so deduce whether an identical hollow cylinder made of gold would also float. Assume that the volume of gold is the same as the volume of brass. So we can see that the density of gold and density of brass is shown. So we know that the volume of gold is going to become equivalent to the volume of brass. So in this case, if you look at the values that we have found, right, 7.3, we know that that's the mass of the cylinder. So what we're going to do is we can multiply that by the 8.7. I'm just going to look for some values here. Is it related to the questions above? No. Okay. So in this case, yeah, okay. You can see that density of gold. So the density of brass. So this is a hollow brass cylinder. So we know that the mass of that is going to be that. So the mass of cylinder. So we know that the mass is going to become equivalent to 8.725 times 10 raised to the power negative 3. This is the mass of brass. Okay, and we know the density of brass is given, so indirectly we can find out the volume. So the volume is going to be equivalent to the mass divided by the density. So we're going to find out the volume of brass. So the volume of brass is going to be the mass of brass, which is 8.725 times 10 raised to the power negative 3, is going to be divided by the density of brass, which is 8.7 times 10 raised to the power 3. Which is going to be equivalent to, by the way, do write your units. So in this case, I'm just, actually I'm going to write the units. Very important. So kgs divided by kgs per meter cubed. So we're going to put this in our calculator, and we're going to get 8.725 times 10 raised to the power negative 3 divided by 8.7 times 10 raised to the power of 3. And it's going to give us 1.00 times 10 raised to the power negative 6 meter cubed. Now this is the volume of brass, and we know that this is also equivalent to the volume of gold. So indirectly, we can say that the volume of gold is the same as the volume of brass. Now, in this case, we know that the volume of brass is going to be equivalent to the volume of gold. So what we have to do is we have to calculate the mass of gold. So the mass of gold is going to become the volume times the, the volume times the density. So the volume in this case is going to become 1.00 times 10 raised to the power of negative 6. We know the volume of brass is equivalent to the volume of gold. We're going to multiply that by the density of gold, which is 19.3 times 10 raised to the power negative 3 kilograms meter per cube, which is going to be equivalent to, so now once we plug in these values into our calculator, right, we'll plug it in, 19.3 times 10 raised to the power 3, you're going to get a value of roughly about 0.0193 kilograms. So this is going to become the mass of gold. Now we can calculate the volume of water required. Now this is going to be the volume of water required. Now in order to do this, we have to do 0.0193, and we're going to divide it by the by the density of water. So the density of water is given to us here as 1.0 times 10 raised to the power of 3. So we're going to divide it by the density of water. So it's 1.0 times 10 raised to the power of 3. Is it negative 3 or positive 3? Yeah, it's positive 3 kilograms meter per cube, and we know that this is in kilograms. So indirectly, we're going to calculate the volume required, since we know that volume is equivalent to the mass over density. So if we put this in our calculator, 0.0193 divided by 1.0 times 10 raised to the power of 3. So this is going to give us a value of about 1.93 times 10 raised to the power negative 5 meter cubed. Now this is the volume of water required. So they're asking us to deduce that the volume of gold is the same as the volume of brass. So since the volume of water required is 1.93 times 10 raised to the power negative 5 meter per cube, this is greater than 1.39. The reason is because this is greater, right, than 1.39. So we have to find out where that part is. We have to equate it with something above here. I'm just trying to search for that. Usually these questions are, yeah, okay, so the volume here, we have found out the volume of the cylinder, so this is greater than the 1.38. So 1.39 times 10 raised to the power negative 5 meter cubed. So I just rounded this value of volume here to 1.39 times 10 raised to the power 5. 10 raised to the power negative 5. So indirectly, therefore, this will sink. So it sinks. So the hollow cylinder made of gold would also float. No, it would sink in this case because 1.93 times 10 raised to the power 5 meter cubed is greater than 1.39 times 10 raised to the power negative 5 meter cubed. So therefore, it will sink. Now, this is something that you can answer for about 4 marks. So let's move on to the next question. Now, the next question, question 16, is that the photograph shows a toy pinball machine. The launcher is pulled back, compressing a spring. The spring obeys Hooke's law. When the launcher is released, the spring returns to its original length, and a small ball is launched horizontally into the machine. So we can see a diagram. When the launcher is pulled back, the spring is compressed by 5.0 centimeters. When the spring is released, the ball is launched at a speed of about 8.0 centimeters per second per second actually. So show that the kinetic energy of the ball after launching is about 4 times 10 raised to the power negative 5. So what we're going to do is, we know that 1 meter is equal to 100 centimeters. So we know the kinetic energy formula. It's in your equation sheet again. So the kinetic energy formula is EK. So we're going to half mv squared. So we know the mass is in grams. We have to convert all of these values now. So in order to do that, we have to convert first the speed. And the velocity is going to become 8.0. Since it's centimeters, it's going to be divided by 100. So it's going to be 8 divided by 100. So it's going to give us a value of about 0.08 meters. So meter second. So and the mass is 1 kilogram is equivalent to 1,000 grams. So indirectly, your mass of the ball, which is 12 grams, is going to be 12 divided by 1,000, which is going to give us a value of about, convert all your values, 0.012 kilograms. So now we can plug this into our equation, the kinetic energy equation. So half times the mass, 0.012, times the velocity, 0.08 squared. So yeah. This should be giving you an answer of about roughly 0.012 times 0.08 raised to the power of 2. It should give you a value of about 3.84 times 10 raised to the power negative 5 joules. So this is roughly, if you round this off, it's going to give you EK is equal to 3.8 times 10 raised to the power negative 5 joules. Now you can round this off to 4 times 10 raised to the power negative 5 joules. It's in this case, that's also okay. So yeah, let's move on to the next question. Now, determine the force in the ball when the spring is released. Now, the force in the ball, what we have to do is we have to equate that the elastic potential energy, right? Elastic potential energy in this case is going to equate to the kinetic energy, right? So that means that the elastic strand energy is going to equivalent to the kinetic energy. So we know that the elastic strand energy is equivalent to half f of change of delta x, okay, change of x. So this is going to become half times the force times the change of x. Now this is because it's compressed by 5 centimeters. We're going to use the 5 in this case to 1 meter is equivalent to 100 centimeters. So we know that 5 centimeters is 5 divided by 100. 5 divided by 100 in this case should give us a value of about 0.05 meters. So 0.05 meters equivalent to the kinetic energy formula in this case, so just 3.84 times 10 raised to the power negative 5 joules. Once you do that, you're going to equate this. So we're going to multiply this, so you get 0.025 force. So 3.84 times 10 raised to the power negative 5. This is just basic algebra substitution. So force is equivalent to 3.84 times 10 raised to the power negative 5 joules divided by 0.025 meters. So the force is equivalent to, let's say, 3.84 times 10 raised to the power negative 5 divided by 0.025. It's going to be equivalent to 1.536 times 10 raised to the power negative 3 newtons. So this is going to be your answer. Your answer is going to be 1.5 times 10 raised to the power negative 3 newtons. Okay, so we have just equated the elastic strain energy formula, which is equivalent to the kinetic energy formula. Okay, so it's going to become 1.5 times 10 raised to the power negative 3 newtons. All right, let's move on to the next question. Now, determine the stiffness of the spring. We know that Young modulus. We have to find out the stiffness, so you don't need to use the Young modulus in this case. So actually, what you're going to use is just use Hooke's law. So Hooke's law is Fkx, right? So F is equivalent to K of change in x. So we know that the force in this case is 1.536. So all we need to do in order to determine the stiffness of the string is just the force divided by the change in x. So the force is 1.536 times 10 raised to the power negative 3 newtons divided by the change in x, which is roughly about, since we know the compression of the spring is about 5.0 centimeters, it's going to become 0.05 meters, 0.05 meters. This is going to give us a stiffness about 1.536 times 10 raised to the power negative 3 divided by 0.05. That's going to give us stiffness about 0.03072 newtons per meter. Okay, so this is going to give us a final answer of about 0.0. It's 30, right? Yeah, 30. So K is going to become equivalent to 0.03 Newton per meter. 0.03 newtons per meter. Okay, this is going to be your answer in this case. 0.03 Newton per meter. Yeah. Okay, so this question is: the spring returns to its original length. Sketch a graph on the axis below to show how the velocity of the ball varies with the length of the spring. So we know that the velocity of the ball, if you scroll up, is about 8 centimeters per second. So we know that it's going to be 8 centimeters per second. So in this case, if you'll reload the system, it's 8 centimeters per second. So we know that it's going to be 8 centimeters per second somewhere around here. Okay, just going to draw that again. So it's going to be 8 somewhere around here. And we're going to draw a curve upwards and all the way touching L and dotted line. Okay. And yeah, this is the length of the spring. We have shown all the axes. This could be centimeters per second. You can mention that this is the speed in this case, slash centimeters per second. This is the length of the spring. And yeah, it should somewhere reach L in that case. Okay, let's move on to the next question. Okay, so what the thing is, for the graph again, just saying that one mark will be the line has initially has a decreasing positive gradient, and the line starts at velocity of 0 and has a non-zero value of length, and we can say that the line levels off to a horizontal at the length of L, and the final velocity should be marked as 8.0 centimeters per second. Okay, so this is something that we have to understand here. Okay, let's move on to the next question. Now, next question is about Stokes' law. A small sphere is moving horizontally. We can see that through a viscous liquid, Stokes' law can be used to calculate the drag force on an object. State the conditions that must apply for Stokes' law to be valid. Is that the object must be a sphere. Okay, the object must be a, let's say, the object must be a sphere. Okay. And it should have low speed. It should have low speed and velocity. So it should have low speed and velocity, and it should have laminar flow. Okay, so the object must be a sphere. It must have low speed or velocity, and it should have laminar flow. Now there's a constant force about 2.3 times 10 raised to the power negative 5 and acting horizontally on the sphere. We know the diameter of the sphere to be about that. We know the viscosity of the liquid at one instant. The speed of the sphere is 5.2 times 10 raised to the power negative 3. Calculate the horizontal force on the sphere. So now we're going to use a formula of Stokes' law. Now this is in your equation sheet. This is going to be the force is equivalent to 6 pi eta, which is the viscosity, and RV. Okay, so we know the radius. So first of all, what we have to do is we have to calculate the resultant force. So this is something that's acting horizontally on the sphere. We know the speed of the sphere. We have to calculate the horizontal resistance. Not the horizontal resistance, the resultant horizontal force. So in this case, we know the diameter of the sphere is about 4.5 times 10 raised to the power negative 3. So what you have to do is 4.5. You just need to divide it by 2. So we know the diameter, right? The radius. In order to find out the radius, you do diameter divided by 2. This is going to be 4.5 times 10 raised to the power negative 3 divided by 2. This is in meters, which is going to give us a radius of about 4.5 times 10 raised to the power negative 3 divided by 2. This is going to give us a value of about, let's say, 2.25 times 10 raised to the power negative 3 meters. Now what we're going to do is the force is equivalent to 6 times pi times eta, which is the viscosity, 7.1 times 10 raised to the power negative 2, times the radius, 2.25 times 10 raised to the power negative 3, times the velocity, in this case is 5.2 times 10 raised to the power negative 3, alright? So the force is equivalent to 6 times pi times 7.1 times 10 raised to the power negative 2, times 2.25 times 10 raised to the power negative 3, times 5.2 times 10 raised to the power of negative 3 again. This is going to give us a final answer of about the final answer of about 1.565 times 10 raised to the power of negative 5 newtons. So now the resultant force in this case, since we know at the top, if you scroll up, there's a constant force. So what we're going to do is the resultant force is going to become equivalent to 2.3 times 10 raised to the power negative 5. You're going to subtract that with 1.565 times 10 raised to the power of 5 newtons. So this is going to give us a resultant force of about 2.3 times 10 raised to the power negative 5. Subtract 1.565 times 10 raised to the power negative 5. This is going to give us a value of about 7.35 times 10 raised to the power negative 6 newtons. Okay. Now this is going to be a resultant force about 7 times 10 raised to the power negative 6 newtons. 7 times 10 raised to the power negative 6 newtons. Okay, now this is going to be your answer for about 3 marks. Yeah, okay. Now calculate the maximum speed of the sphere in the horizontal direction. So what we're going to do is, since we have to calculate this, we're going to use the same formula again. We know that the force is 6 pi eta RV in this case, and the maximum speed in the horizontal direction. So we have to use the horizontal direction force, or the speed in this case. So the horizontal direction, it has the force here. We're going to use 2.3 times 10 raised to the power of 5. So 2.3 times 10 raised to the power negative 5 is equivalent to 6 pi. The eta, we know the viscosity to be about 7.1. So 7.1 times 10 raised to the power of negative 2, right? Times the radius. We know the radius to be about 2.25 times 10 raised to the power negative 3. And the velocity, which is going to be v in this case. So what we're going to do is, we know the velocity is going to become equivalent to 2.3 times 10 raised to the power negative 5 divided by the value that we have calculated here. So that value is going to be 6 times pi times 7.1 times 10 raised to the power negative 2. That's going to be times 2.25 times 10 raised to the power negative 3. This is going to give you a value of about 3.0112 times 10 raised to the power negative 3. Okay, so it's going to be equivalent to 2.3 times 10 raised to the power negative 5 divided by 3.0112 times 10 raised to the power negative 3. It's going to give us a value of about, let's say, 7.638 times 10 raised to the power negative 3. meters per second. So it's going to give you a final answer of about velocity is equal to 7.6 times 10 raised to the power negative 3 meters per second. So 7.6 times 10 raised to the power negative 3 meters per second. Now this is going to be answer if you round it off. So 7.6 times 10 raised to the power negative 3, yeah, meters per second. Now this is the correct answer. All right, let's move on to the next question. Okay, so a large diameter sphere in the same liquid is acted upon the same constant force. The liquid is at a lower temperature. Explain the effect of these changes they have on the maximum speed. So this is for about 4 marks. So you can say that the large diameter, it gives, like, let's say a larger drag force. A larger drag force at the given speed. You can also mention that the lower temperature, so viscosity is greater. So viscosity is greater. We can also mention that the greater viscosity, right? The greater viscosity means it gives a larger drag force at given speed. And you can also mention that the maximum speed will decrease. It will decrease, okay, and depending on the large diameter, right? Depending on large diameter and low temperature. Okay, so we can actually cut that out. So we can just say that the maximum speed will decrease. That's more than enough. So we can say that a large diameter just gives a larger drag force at given speed, or we can mention that the large diameter gives a lower speed, let's say for the same constant force. And then we can mention that the lower temperature, so the viscosity is greater. You can also mention that the viscosity actually gives a larger drag force at a given speed, or we can mention that the greater the viscosity, it gives a lower speed for the same constant force. So indirectly, this will all cause it to have a maximum speed, which will decrease. So you can answer this for about 4 marks. Let's move on to the next question. Now, the next question is: a stunned motorcyclist wants to jump across a river to land on the other side. The diagram shows a motorcycle driving off a ramp at the edge of the river, so you can see that. And the ramp is inclined at 25 degrees to the horizontal, and height at the end of the ramp is about 3.0 meters. The width of the river is about 100 meters. The initial velocity of the motorcyclist is about 35 meters per second. Calculate the horizontal and vertical components of the motorcycle's initial velocity as it leaves the ramp. So now, in order to do this, what we have to find out is the velocity. In this case, the horizontal component and the vertical component. So from the ramp, it moves about that for about 35 meters per second. So the horizontal, in this case, the horizontal axis is going to become, the force is going to be 35 times the cos of 25 degrees. 25 degrees. Now this is going to be roughly about, let's say, 31.7 meters per second, which is going to become equivalent to 32 meters per second. And your vertical component, which is Vy, is going to become 35 times sine of 25 degrees. Okay, so that's going to be 35 times sine of 25. So that's going to give us a value of about 14.79 meters per second. You can round this off to about 15 meters per second. So you're going to get your horizontal component as 32 meters per second and your vertical as 15 meters per second if you round them all up. Okay, so yeah, Vx is going to become 32 meters per second, and Vy's vertical component is going to become 15 meters per second. Okay. Meters per second, 32 and 15 meters per second. Yeah, this seems correct. Okay, let's move on to the next question. Now, deduce whether the rider lands on the other side of the river. The effects of air resistance can be ignored. So, what we have to do is we have to use some certain formulas. You can use the correct, like, SUVAT equation in this case. So, so the time taken in this case is going to become, we have to use distance speed over time, so DST formula. So we know that the time is equivalent to distance over the speed. So we know that the distance is roughly about 100 meters. So we can see that the width of the river is 100 meters. So we're going to do 100 divided by your, let's say, your horizontal, we're going to do 100 divided by the horizontal component. So it's going to be 100 divided by the speed in the horizontal component, which is going to be 31.7 meters per second, and 100 meters. This is indirectly going to give us the time it takes, so 100 divided by 31.7. So that's going to give us roughly about 3.15 seconds. So next one, since it's 3.154 seconds, so now what we're going to do is we're going to calculate the vertical displacement. So in order to calculate, let's say, the vertical displacement, what we have to do is we have to use some of the SUVAT equations in this case. So we're just going to analyze this. So what we can see here is we can see that the vertical in this case is, we have to calculate the vertical part. So what we're going to do is we're going to use the speed of y. So it's going to be s. Actually, we're going to use the SUVAT equation. One of them is going to be in your formula sheet. So it's going to become s is going to be equivalent to ut plus half at squared. So in this case, we're using, remember, we're using the vertical displacement. So the speed in this case is going to be the vertical component of velocity, which is 14 where we're getting this value, we're going to get this from the vertical component speed. So 14.78. So 14.7, sorry, not 14.78, it's actually going to be 14.79. 14.79 times the time, which we have found out is 3.154, all right, minus, since acceleration is going to be negative, right? We know that the acceleration is going to be a negative g. So that's why we have put a negative sign instead of a positive sign. Okay, so it's going to be negative half times 9.81 times the time in this case, which is again 3.15. Sorry, 3.154 square. Now, what I like to do is, we can do 4.79 times 3.154 minus half, which is going to become times 9.81 times 3.154 raised to the power of 2. If you put that in your calculator, you're going to get negative, right? Some form of negative 2.14 meters. So we know that it's going to become equivalent to negative 2.1. I'm just going to put this in brackets just to see if this is correct, because sometimes if you plug in all the values in your calculator without using brackets, it's not a very good idea. So what you have to do is use brackets always. So the first thing I would advise is whenever plugging in values into your calculator, just put the brackets there so it helps you guys to understand it. So I'm just going to confirm, yeah, it's negative 2.14, so it's going to be negative 2.1 meters. Negative 2.1 meters. So we know that we know that 2.1 meters. Okay, we know that 2.1 meters, and we look above in the question, and the height of the end of the ramp is about 3.1 meters. So the rider is most likely to land on the other side. So 2.1 meters is less than 3.0 meters. So the rider, he lands on the other side. He lands on the other side of the river. I'm just going to write this down properly. So the rider, I'm just going to write this down, yeah. So the rider lands on the other side of the river. Since 2.1 meters is less than 3.0 meters, the rider will land on the other side of the river. Okay, so we can move on to the next question. Explain how air resistance would affect the jump. So since this is for 3 marks, we have to say that air resistance, okay, you can say that air resistance, it acts to oppose the motion of the motorcyclist, so indirectly, so it decreases the time, let's say the time for which the motorcyclist is in air, okay, and you can mention that the horizontal distance traveled, the horizontal distance the horizontal distance traveled is reduced. Okay, is reduced. So explain how air resistance would affect the jump. In order to answer that, we have written down all the 3 points. You can just mention that the air resistance, it just acts to oppose the motion of the motorcyclist. So indirectly, this decreases the time for which the motorcyclist is in the air. Or you can mention that there's a deceleration in the horizontal direction, or speed in the horizontal direction is reduced. And you can also mention that the maximum height that's reached by the motorcyclist is reduced. And the final point that you have to write down for 3 marks is that the horizontal distance is traveled is reduced indirectly. So, yeah. Those are 3 points for about 3 marks. Have we mentioned the maximum height? Oh yeah, we can also mention that, you have to mention that in this question, that the maximum height reached by the motorcyclist is reduced, or you could just mention that point so it decreases the time for which the motorcyclist is in air. Those 3 points should be okay. This seems to be the end of all the questions. So as you have seen, that the formula sheet is in the end pages. Actually, the formula sheet is in the last page of the paper. Okay, so you guys can check that out. This seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe. The channel really helps a lot. And do comment below on what your thoughts are about this video. Have you guys enjoyed it? And yeah, I think that's it. Alright, bye guys.